Hi there, welcome to AK Online Academy. This is Tutor Abednego speaking. Alright, so in today's lesson, we're going to look at speed time graphs. This is one question that never misses in Mathematics Paper 1, both for the grade 12s and the GCE candidates. This is usually the last question in the exam paper. Okay, so we're going to first of all start by looking at how to find the distance for the various shapes. Usually you're going to be dealing with three shapes: a right angled triangle, a rectangle, and a trapezoid or trapezium. So I'm first going to look at how we can calculate distance for these particular shapes, and then we're going to start with the introduction to speed time graph. We're going to look at the formulas that we're going to be using and all that. Right, so let's start by looking at how we can calculate distance for right-angled triangles. So the formula for calculating distance for right-angled triangles, so you're basically calculating the area, but when you're dealing with speed time graph questions, you're going to say distance instead of saying area. So the formula is D is equal to 1 over 2 BH, okay, where B is the breadth and then h is the height. So simply plug in these values. So meaning for this particular triangle, our h is 7 and then our b is 4. So to calculate distance for this particular shape, we're just going to say d is equal to 1 over 2, distance is equal to, then we're going to say times, what is our b? Our b is 4, times our h, which is 7. Okay, so distance is equal to, so since this is multiplication, we can say 2 there 1, 2 there 2, meaning it's going to be 2 times 7, giving us distance as 14 meters. So whenever you're calculating distance, you always use meters as the SI unit. Okay, we're done. We come to this other one, so meaning this is our height and this is our breadth. So distance is equal to 1 over 2. So now these formulas, you need to make sure that you master them. Okay, you need to make sure that you master them because they will not be provided for you in the exam. What the formulas we're going to look at today. So 1 over 2 times b is 3 times h, which is 6. So again here you can say 2 there 1, 2 there, that's a 3. So meaning distance will be equal to 3 times 3. Okay, this 3 here times that 3 there. So meaning distance is going to be 9 what? 9 meters. And we are done. So that's how we calculate distance for a right angle triangle. We proceed to a rectangle. Okay, so the formula for a rectangle is simply distance is equal to L times B, okay, of which L is the length, so this is going to be our L and then this is going to be our B. So distance is going to be equal to, our L is 9, okay, 9 times our B, which is a 3 down here. So this value is the same as what we're going to have up there. So distance will be equal to 9 times 3, that is 27 meters. Come to this other one. So this is our L, this is also our L, this is our B, and that is also our B. So distance is equal to L times B. Distance will be equal to, so again these values may not be up to scale. Okay, as you've noticed, this length here from here to here, okay, is bigger than this length, is seemingly longer than this length from there to here, but you've noticed that this value is smaller than this one. So these values are not up to scale, like whereby just by looking they should be the bigger length, the seemingly bigger side should have a greater value compared to the smaller one. Okay, so please take note of that. I just did this deliberately to prepare you for what we're going to be dealing with in the questions. Sometimes you find that this distance from there to there, okay, there to there, you can see it's longer than this distance from there to there. Okay, but the value for this distance is 3. while the value for this distance is what? Is 7. Okay, so that is that when dealing with these questions. Sometimes the smaller part may have a bigger value, while the bigger part may have a smaller value. So meaning our distance here will just be equal to 21 meters, and we are done. Okay, we go to the next one. Okay, so we now look at a trapezium. So a trapezium is the same as a trapezoid. They are one and the same thing. And this shape is not complicated. It is basically just a combination of 2 triangles and 1 rectangle. Okay, so there are 2 types of trapezoid. It could be a combination of a triangle and a rectangle, or a combination of 2 triangles and a rectangle. So you've noticed to say this triangle is coming to attach to this point, and then it's going to look like this here. Okay, and then when this one is attached, this space is closed up, this is what you're going to have. So if you want to, in case you have forgotten the formula for calculating the distance of a trapezium, you can simply calculate for the triangle. Okay, you can call this one distance 1. You calculate for the triangle, you come to the rectangle, and then you come to the other triangle, then you add everything at the end, then that will give you the distance for the trapezium. Okay, otherwise that's how you form up a trapezium. You simply combine the triangle and the rectangle. So it could also look like what is that other example? It could also look like this. You've noticed here they've just combined, I've just combined 1 triangle and this rectangle. Okay, the other triangle is not there. So this is the same as what we are going to look at with the other trapezium. The formula is the same. It doesn't really matter whether it has 2 triangles on the side or it's just 1. Sometimes even these lines may not be indicated. These dotted lines may not be indicated. Okay, but that doesn't make it a different shape. It's still going to be a trapezium. Okay, so now let us look at an example. So the formula for finding the distance of a trapezium is distance is equal to the common one is this one, 1 over 2 a plus b height. Okay, but I prefer to use this one, which is going to be a plus b times height, then everything over 2. All you have done is you have multiplied 1 times everything here. It gives you everything there up there. Okay, and then the 2 just comes down here. So I prefer using this one here compared to this one. So you can use whichever one you're going to be comfortable with, but for me this is the one I'm going to be using in the solutions video. So I'll say distance is equal to open bracket a plus b close bracket h, then everything over a 2. Now we need these values a, b and h. Which one is a, which one is b, and which one is h? So for a and b, these simply represent the parallel length. So there's this length from there to there. Okay, this one here. Okay, this distance from there to there, and then there's this longer one down here. Okay, which is from there to there. Okay, so you notice to say the one on top is slightly smaller than the one down here. Okay, it's not always that they're going to be slightly smaller. If you remember from the previous session, you notice that the top one, this one, is actually shorter because it's ending there like that, and then the one down here is starting all the way from there. Okay, and ending here. So it ends there, then even here it ends here. Okay, so these are the parallel lengths. So now which one is a and which one is b? It does not matter which one you're going to assign as a and which one you're going to assign as b. You are still going to get the same answers. So we can call this one up here, we can call this one a. Okay, and then we can call this one down here b, or if you want you can call the one down here a, and then the one up here b. You are still going to get the same answers. Okay, although for me I prefer calling the assigning the A to the shorter length, and then the longer length I assign it B. That's just my preference. Okay, you may go with whichever method you prefer. Otherwise, it doesn't really matter which one you assign as A or which one you assign as B. And then the height, now the height matters. Okay, the height can only be assigned to this distance from there. Okay. Just clear up this, press the wrong button. Okay, so now the height is basically the height of a triangle. You notice there is a triangle here. Okay, there's this triangle right there. You have this triangle here. So basically the height of the triangle, that is your height here. So the height of the triangle is just represented by h. So meaning the distance from there to here, this distance, that's your height. So it can be this side or it can be this side. That is your h. So now that we have figured out how to identify these sides, we can now plug in the values and then solve. So let's put our h this side where there is 3. So you can simply say distance is equal to, what is our a? The a we have assigned is 6, okay, in brackets, plus what is the b? The b is this one here, 8. This is our b. So 6 plus 8, okay. The height is a 3, okay. Everything over 2. So distance will be equal to 6 plus 8 there gives us 14 times 3 over 2. Okay, what am I doing? Okay, so let's take it up here. So distance is equal to 14 times 3, everything over 2. Now remember, this is paper 1 and you do not have a calculator. So instead of saying 14 times 3, then the answer I find I divide by 2, I can simply say 2 there, 1, 2 into 14, that is 7 times 3. Meaning my final distance will be equal to 21 meters. And I'm done. Okay, we go to the next one. So we're going to say, so if you want, you can prove whether what we've done is correct. Actually, let's prove. Okay, 14 times 3 over 2. 3 times 4 there will give us 12. Remainder 1. 3 times 1 is 3, plus that one remained, that's a 4 over 2. 2 into 4 is 2 into 1, 1. So whichever way you do it, but for me I prefer doing it the easy way, which is you reduce there 1, you reduce there, gives us a 7, then 7 times 3 here gives you a 21 there, and we are done. Okay, we now go to the other example of a trapezium. So let's assign again. This will be our a, this will be our b, and then this is our h. So the formula, remember, is distance is equal to, open bracket, a plus b, close bracket, height, everything over 2. So meaning distance will be equal to, what is our a? Our a is 6, okay, this one right here. Our b is 8, so 6 plus 8. Our height is a 7 here, okay, 7, then everything over 2. So we're going to say distance will be equal to 6 plus 8 there in the brackets, we get a 14. Okay, nice. Over 2. So distance would be equal to we have different values. Okay, so here again, instead of saying 14 times 7, then I start dividing by 2 at the end. I'll just say 2 there 1, 2 there 7, then 7 times 7 gives me a 49. So 49 meters, and we are done. Okay, we go to the last one. So sometimes you may have such a shape. This is still a trapezium, it's just that it's rotated. It's more like it's standing, it's upright. The other one, the previous ones, you can say they could have been in landscape because they are lying flat like this. Okay, and then the other one now is upright. So the principle is just the same, the formula is just the same. Open bracket, a plus b, close bracket, you have your h there, everything over a 2. Distance will be equal to, so this will be our a, this will be our b, and then this will still be our height. So a is 6, so it's going to be 6 plus our b is 10. Okay, 6 plus 10, our height is 3 down here. Okay, height is 3, then everything over 2. Now let me just make mention something. It is wrong for you to say 2 there 1, 2 there 3. That is going to give you wrong values. You need to first of all add, then the answer you find, that's when you can reduce like that. Okay, meaning here I'm going to add 6 plus 10 giving me 16. Okay, times 3, then everything over 2. At this point I can now reduce 2 there 1, 2 into 6, that's 8. So it's going to be 8 times 3 giving us, that is 24 meters, and you are done. Okay, now we can proceed to our introduction of speed time graph. So now speed time graph is basically well, you're going to be given scenarios. A particle moved from what to what point uniformly at a speed of this, and then it came to rest, stuff like that. Okay, what you just need to know is how to find acceleration, how to find retardation, how to find speed, how to find distance. Okay, those 4 things. We've already covered distance, we already covered speed in the session, one of the previous sessions when we were looking at earth geometry. The same formula you're using for earth geometry, speed is equal to distance over time. Okay, the same formula we're using for average speed, which was speed is equal to total distance taken, total distance covered over total time taken. The same stuff. Okay, so we already know speed, we already know distance by now. Now we just need to know how to find acceleration and retardation, which are just opposites. Okay, and the formula, they use the same formula. All right, so now think of this as the x or y plane. This is your y-axis and this is your x-axis, except they have different names. This is an axis. The y-axis is an axis for speed, which is measured in meters per second. That's the SI unit. Whenever you're calculating speed, make sure your final answer should be meters per second. Whenever you're calculating time, okay, it should be in seconds. That's the SI unit for time. Okay, so it's called a speed time graph because it's an axis for speed, which is this one here, the one going up, this one, this arrow here. This is the axis for speed, and then this one down here is for time. Okay, so this is an axis for time. So now we have a speed, time, and then this is your graph. This one, that's your graph, speed time graph. That's where the name of the topic is coming from. Okay, so now this is the axis for time, right? Meaning all the values here are representing time. 0 is a neutral point. No wonder I colored it differently. So it is both for speed and time, just as the 0 when you're dealing with coordinate geometry, you are dealing with the x or y plane. The 0 is a neutral point. It belongs to the x-axis and also the y-axis. No wonder if you notice the 0 has red representing the speed here and black representing the time. So now all the values on the axis for time here, okay, all these values, we have 4. Let me start from 4. Okay, we have 4, we have 20 and 16. All these represent time. Okay, and then on this axis, which is for speed, we say this one is for speed, this axis. So meaning all the values that are going to be on this axis are going to be representing what? Speed. So if you want to find the speed of the particle, okay, or whatever it is that you're looking at, whether it's a car, a cyclist, a runner, okay, what is the speed at this point? You need to come to the axis for speed and then you check. So meaning there, the speed is 10 meters per second. How about here? What is the speed at this point? You need to come here and check. Just the way we're checking to say if you have a point, you have your x or y plane. Okay, you have a 0 there, that is your x-axis, that is your y-axis. Okay, and then you're told there's a point here. To find the x coordinate, you need to drop down to the x-axis. You check there. Let's say you have a 3 there. Okay, to find the y coordinate, you have to come to the y axis and check. Let's say you have a 4 there. So same applies here. Okay, to find the time at any given point, what is the time at this point? You need to drop down to the axis for time, and then you check what is the value that is at this point. Okay, you want to check the speed at this point, you need to go to the axis for speed, and then you check the value that is right there. So that is basically that. And then when it comes to the formulas, the formula for finding acceleration is given by acceleration represented by an a, small letter a, okay, is equal to v minus u over time, where a is acceleration. Okay, acceleration, and then v is final velocity, and then u is initial velocity, initial v, where t is time. So now what is important is knowing these two, final velocity and initial velocity. You need to be able to differentiate. Some students have issues figuring out which one is initial velocity, which one is final velocity. Okay, excuse me. Final velocity simply means the final speed of the particle. Let's say the particle moved from, let's say it moved from here. Let's call this one point A. Let's call this one point A, right here. Then it moved up to here. Okay, let's call this point B. The final velocity is the value at B. The final velocity, simply refers to speed. Okay, so the speed, the final speed is going to be 10. Since the particle moved from here to point A, from point A to point B. If, for example, let's say we had maybe 6 here, and the particle moved from A to, let's call this point C. Okay, your v at this point is going to be what? 6. Because where the journey ended from, it started from here, came up to there. Where the journey ended from, the value there, you check on the axis for speed, that is going to be your v. So many v is going to be 6 there. If the journey is starting from here, let's call this one point D, and it's ending right here. Okay, it came to rest at E, meaning the journey started from there, it came and then it reached there. Where the journey ended from, so meaning your v is going to be picked from there. Okay, so how do you pick the v there? You need to go now to the axis for speed. Okay, you're going to pick it from there, which is going to be a 0. So meaning your final velocity there is going to be 0. It doesn't mean that final velocity can't be 0. No, it depends with where the journey is starting from and where it's ending. Okay, so that is how we pick those values. When it comes to u, the initial velocity, it simply represents the value for the speed where the journey is starting. Okay, let's say they've told you to say this particle moved from point, let's put point A here again. Okay, point A right here to point B. The starting point, okay, we have 0 there. That is going to be the value for u. It is 0 meters per second. Remember I said velocity is simply speed. Okay, if the journey started from point C to point D here, your initial is going to be picked from where the journey is starting from, right there. So how do you know what value that is for speed? You go to the axis for speed, you check, meaning the 10 meters per second, that will be your initial there, 10 meters per second. If the journey started from here and ended here, okay, let's call this one E, and then let's call this one F. The journey started from there and then it ended there. Your initial is the starting point, so you go to the axis for speed, you check what value is there. That will be your initial velocity. So that is that. Then retardation uses the same formula as the one for acceleration. Okay, retardation simply means the particle is slowing down. Accelerating, it is gaining momentum. So retardation is simply the same, v minus u over time, except the final value is going to be a negative. Retardation is also known as deceleration, and deceleration is known as negative acceleration. That is why the answer for retardation or deceleration is going to be a negative value. Okay, now that we've looked at that, we can now look at an exam question. So the question says, so now be very careful, pay attention to the question. They are going to give you valuable information sometimes right in the question. Sometimes they'll just describe how the particle moved, but then sometimes they'll give you valuable information which you are supposed to use to solve some of the questions. So be very careful as you go through the question. So the question says, the diagram below shows the speed time graph of an object. The object accelerates uniformly from O to P. Okay, let me start again. The diagram below shows the speed time graph of an object. The object accelerates uniformly from O to P until it reaches a speed of 20 meters per second in 4 seconds, and then moves steadily from P to Q for 6 seconds and finally comes to rest. Okay, so they are just describing how this particular object moved. So I thought to say it moved from O to P. Okay, in how long? Since you want to check the time it took, you come down here, you check for the axis. Okay, it took 4 seconds. Remember, time is in seconds. It took 4 seconds for this particular object to move from O all the way to what? All the way to P. Okay, and then so this object started from rest. That is why it's starting from 0. Okay, is this 0 or O? Anyway, we're supposed to have a 0 here, so we'll go with 0. Okay, so it started, okay, let's go with O, but we know to say the value here is 0 since that's a neutral point. So it started from rest, okay, moved up uniformly, so like it was accelerating at a uniform speed, and then it got to this point. Okay, so what was the speed at this point? You need to check now the axis for speed here. What is the value there? The speed was 20 meters per second, and then it moved at 20 meters per second from P to Q. You notice to say here this was constant speed. It was just moving at 20 meters per second. Okay, how long did it take to move from P to Q? You need to drop down to the axis for time. Okay, you're trying to check the time from there to where? Here. Okay, so here you have a 10 and there you have a 4. To find the distance from there to there, or the time it took to move from there to there, you simply say 10 minus 4, meaning here you're going to have 6 seconds. That's how long it took to move from P to get to point Q. Okay, and then it decelerated uniformly from point Q to this point here. Okay, where it got to rest. How long did it take for this particle to move from there to there? From Q until it got to rest here. How long did it take? You simply drop down. Okay, check what is the value there. It's 10. And then what's the value there? Simply say 15 minus 10 to give you 5 seconds. So it took 5 seconds for it to move from there to there. Okay, so that is basically how this particular particle moved. So this is the graph that you're going to be considering, nothing else. These other lines are just axes. This one is for speed, okay, this one this side, and then this one is for time right here. Okay, now that we have understood how this particle moved, we can now go to the business for the day, which is answering these questions. So now the question says, question A says acceleration, find the acceleration in the first what? 4 seconds. So you go, where is the first 4 seconds? The first 4 seconds is here. Okay, from there to okay, the first 4 seconds is basically the distance from there to here. Okay, so now this particle moved from O to P in the first 4 seconds. So this is what you're going to have. Okay, all right, so this particle moved from O to P in the first 4 seconds. So meaning you need to pick values. Remember our formula is V minus U. over time. So acceleration, that is what they've asked us to find. What is the velocity? The journey is from O to P. So the final is where the journey ends from. So our V is going to be 20. Okay, our initial our initial is a starting speed for the journey. The journey started from O all the way to P. So here we have a 0. Okay, we have a 0 here. So meaning our U is a 0 over the time. They said the first 4 seconds. So time is just 4. So meaning acceleration is going to be equal to 20 minus 0 is 20 over 4. 20 divided by 4, it gives you 5 meters per second squared. So acceleration and deceleration, the SI unit is meters per second squared. That is your answer for that question, and you are done. Okay, we go to the next one. What is the next question saying? Let me clear this place up. All right. Okay, question B. What is question B saying? Calculate the total distance covered by the object. Total distance simply means the distance for the entire shape. Okay, so what shape are you seeing? This is a trapezium. Okay, goes there and then there, comes down here and then down there. So meaning our A is this distance from there to there, like that. This will be our A. And then our B will be the distance from there all the way up to here. Right there, like that. Then our H is the distance from there up to there, like that. That's our H. Okay, that's our trapezium. So now let's calculate what is the distance. So this is A, this is B. Like I mentioned, it doesn't matter which one you assign as A or B. Okay, so distance, what is important is knowing the formula. Make sure you master these formulas. A plus B, height, over 2. What is our distance? So what is A? So A is the distance from P to Q. Okay, how do you find that distance? You simply drop down to the x-axis where the values are, or to the axis for time. So you have a 10 there, you drop down again to this point. Okay, what do you have there? The 4. To find the distance from there to there, you simply say 10 minus 4, giving you what? A 6. So meaning our A here is a 6. So we're going to say 6 plus, what is our B? Our B is a distance from O to 15 here. Okay, so simply say 15 minus a 0, giving me a 15 there. Okay, what is our height? Our height is basically the distance from there to here. How do you check? You're going to get that value from the axis for speed. So the distance from there to there. So you get the value from here, okay, up to there. So I'm going to say 20 minus 0, giving you a 20. Okay, then everything over 2. So distance will be equal to, we can say 2 there, 1, 2 there, 10. 6 plus 15 there will give you 20, what? 21. Okay, times the 10 which remained up here. Okay, so meaning the distance for this particular journey was 210 what? Meters. And you're done. Okay, we go to the last one. Find the average speed. Average speed for what? Saying average speed in the last 4 seconds. Now this is a tricky question. Tricky but doable, this one. In the last 4 seconds. So now if you notice, from here to here, okay, how much time passed? Okay, from this point to that point. You simply say 15 minus 5 minus 10, giving you 5. Okay, so the distance from there, the time from there to there is 5. Okay, now they are saying calculate the average speed in the last 4 seconds. So meaning the last 4 seconds will be 15 minus 4, giving you 11. So let's say here we have 11. Okay, so they want us to find the average speed in the last 4 seconds. So now we need to know, if we take it up like that, let's see, we need to know the speed at this point. Okay, so we need to come this side, come on, need to straighten up. Nice. So we need to know the speed at this point. What is the speed here? We don't know, it's not indicated. Okay, we know to say the time here is 11. Okay, it's 11. Now how about the speed? So how do we find the speed? We're going to use the we're going to calculate the deceleration for the last 5 seconds. Okay, the distance from Q to this point. Okay, what was the deceleration at this point? So I'm going to say retardation or deceleration is equal to V minus U over time. So retardation will be equal to, what is the final? V is final velocity. The journey ends here. It is not 15. You need to go to the speed axis, which is this one. So your final is 0. Okay, the final is 0. Okay, minus, what is the initial? It's starting from right here at Q. Okay, right here. So meaning the initial, to check the initial, you have to go towards the axis here for the axis for speed. So your initial is 20. Okay, so you have 20 there. And then what is the time? Okay, the time is 15 minus 10, giving me a 5. Okay, so retardation is going to be equal to no, we're not done yet. We have to say over 5. So retardation is going to be negative 20 over 5. So R is going to be equal to negative 4 meters per second squared. That is retardation. Now that we know that the retardation from Q until it got to rest was negative 4 meters per second or 4 meters per second, we can now find the speed, because retardation, okay, at this point is the same as at this point. It doesn't change. It's like the gradient. The gradient is basically the slope of a line. It doesn't change at any point. The retardation just before it got to rest was still negative 4 meters per second. The acceleration, now this is important. I'm going to give you an assignment and then I'll need you to use this piece of information I'm giving you. The acceleration from at this point is the same as the acceleration at this point. Same as the acceleration at that point. Okay, so since now we know the retardation for this particular line, okay, any point on this line was 4 meters per second, we can now find the value of the speed there. Okay, so we're going to use the same formula for retardation. Now we're just going to calculate the retardation for the last 4 seconds instead. So we're going to say retardation is equal to V minus U over the time. What is the retardation we found? We found negative 4 meters per second. Okay, the final is 0. It's ending here. It's going to rest. So it's 0 minus U. We don't know. That's the value we're trying to find here. Okay, what is the U? Because the journey is starting here and it's ending right here. It's starting here and ending there. So to check the value for U, we need to go this side and we check. But we don't know the value there, so that's why we've just put a U over, what is the time? The time is 4 seconds. Okay, so that is our, okay, so I think I messed up on the formula. The formula for retardation, you simply swap the values. It starts with U minus V over time, so that you don't end up with a negative value. Okay, so this value is going to be a positive. Okay, so let me just quickly correct what I did. So the initial velocity, let me just take you back a little bit. The initial velocity from here to there, that's the journey we are calculating. The initial velocity, the starting velocity was what? 20. So R will be 20 minus final, which is at this point when it got to rest, which was 0, over the time last 5 seconds. So R is going to be equal to 20 over 5. Then retardation is going to be 4 meters per second. 20 divided by 5 is 4 meters per second. So when you're using retardation, it's supposed to give you a positive value, since you are already saying this is negative acceleration. But when you're using acceleration, okay, that's when you're going to get a negative answer. So meaning these values will swap. The u will come this side, and then the v will come that side. So that is that. Please don't get confused. So when you say retardation, just make sure you start with a u, and then the v should be on the right side. Okay, so when you say acceleration, it is v minus u over time. Retardation is u minus v over time. The idea is for you not to end up with a negative value. Okay, this one will give you a negative answer. Okay, and that will tell you to say this is not acceleration, this is deceleration. The negative will tell you to say this is deceleration. Okay, so now let's restart this one so that I make sure that no one gets left behind. Okay, so we are calculating the retardation for the last 4 seconds. Okay, the last 4 seconds, so it's going to be 15 minus 11, giving us 4 seconds there from here to there. Okay, so meaning we're going to say retardation is equal to u minus v over the time. Okay, so now retardation, we already have it from the previous question. It's 4 meters per second squared. So where there's r, I'm going to put 4. Then I say u, the starting velocity at this point. If you check this side, we don't know the value. It's not indicated here. So we simply say u minus, what is the v? The final velocity. The final one, it got to rest. Whenever it gets to rest, the velocity is 0. Okay, over the time is the last 4 seconds. So that's a 4 there. So we are going to say 4 is equal to u minus 0 is just u over 4, and then there we can say over 1, cross multiply. 4 times 4 gives you 16 meters per second, since that is speed. So that is the value for u. Okay, so now the question is saying find the average speed in the last 4 seconds. So now in the last 4 seconds, what shape do you have? Okay, in the last 4 seconds we have, okay, we have this shape, which is a what? Which is a triangle. Okay, and then the formula for finding speed, the one we looked at when we were looking at earth geometry, speed is equal to distance over time. It is the same as the formula for average speed, total distance taken over total time taken. Okay, so meaning speed is equal to distance over time. Okay, we have time, it's the last 4 seconds, but we need to find distance. We don't have distance, so we need to find distance for this shape right there. Okay, so remember, distance for a triangle is equal to 1 over 2, okay, bh, where our b is going to be this one here, the distance from, so I have an 11 here, remember, so this will be our b and this will be our height. So the reason why we are solving is because we need this value here, which we have found as what? As 16. So the retardation we found, that was 16, so we have a 16 there. We needed that value for us to find the distance for this shape. So meaning we're going to say distance is equal to, our height is 16 minus the 0 there, giving a 16. Okay, so we have 1 over 2 times our breadth is 15 minus 11, that's 4, times the height is 16. Okay, and then we're going to say, we can say 2 there, that's 1, and then 2 into 4, that's 2. So then we're going to remain with 1 times 2 times 16. So meaning your distance is going to be 2 times 16, that is 32 meters. That is your distance. Now that we have distance, we can now solve. So let's put our distance here, it's 32 meters. Now that we have distance, we can now solve for the speed. Remember, trying to find the speed. Okay, so we can now say speed is equal to, what is the distance? The distance is what we just found, 32 over the time. What is the question saying? Distance in the last 4 seconds. So our time is 4. So meaning your speed is going to be 4 into 32, that should be 8. Okay, so that's going to be 8 meters per second. Remember, speed is in meters per second, and you are done. Okay, we proceed to the next one. The next question says the diagram below is a speed time graph of an object. The object starts from rest and accelerates uniformly for 2 seconds until it reaches a speed of 10 meters per second. They're just describing how this particle moved, this object. It then travels at this speed for 8 seconds and finally decelerates to rest after 5 seconds. Okay, at this point, they're just describing how the particle moved. Let us go to the question. Question A says, what are we finding? Find the retardation of the object in the last 5 seconds. Okay, the retardation of the object in the last 5 seconds. So the last 5 seconds is going to be 15 minus 10, giving you a 5 there. Okay, so meaning in the last 5 seconds, it moved from this point until it got to rest here. Okay, that is the last 5 seconds. So let's call this one A and then this one B. This point right here and this point right there. That's the journey we're trying to find. Okay, this is where it started from. It started from A and ended at B. So retardation is R is equal to U minus V over the time. Okay, so retardation is equal to, what is U? U is the starting velocity. So it started from A, okay, and ended at B. So meaning A is U and then B is V, final. Okay, so how do you check the speed at A? You need to go towards the axis for speed. Okay, so you move towards the axis for speed. Check what is the speed at this point. The speed is 10 meters per second. So your U is 10 minus the V is basically the final way it went to rest. Okay, go to rest. Okay, it got to rest, and then so whenever it's at rest, it's 0 meters per second. It's not moving. Okay, or you can simply come here and you check right there. What is the speed there? It is 0. That is where the 0 is coming from. Time is indicated in the question, last 5 seconds. So time is going to be 5. Meaning retardation is going to be 10 minus 0 is 10 over 5. So retardation will be 10 divided by 5, that is 2 meters per second squared. That is the retardation of the object in the last 5 seconds. And we are done. Okay. Now go to the next question. Let's clear up. Okay, what is the next question saying? So question B says, find the distance traveled in the first 10 seconds. The first 10 seconds is the distance from there to there. What shape do you have in the first 10 seconds? So you go up. This is the last point for this distance. Okay, so 10 is here, meaning this distance from there up to there and then down here. That one hasn't come out well. Okay, let go of it too early. So I'm just trying to identify the shape. Okay, this is the shape we have for the first 10 seconds. What shape is this one? It is a trapezium. Okay, meaning you have your A on top here, you have your B down here, and then this is your height, and this is also your height. So we say distance is equal to A plus B height, everything over time. Okay, so what is your A? Your A is the distance from there to there. Okay, so how do you find that distance? We're going to say 10 minus 2. Okay, 10 minus 2 giving you 8. The distance from there, from here to there. Okay, that is 8. So your A is going to be equal to 8 plus, so this distance from there to there is the same distance as from there to there. That's why it's still 8. And then your B is basically the entire 10 seconds. Okay, remember the base, the longer length, so it's 10 minus the 0 here, giving you a 10. That is your B. Okay, and then the height is just erase this guy. Okay, there we go. The height is from there to there. How do you get those values? You come this side. Okay, you check what value do you have there. 10 minus what value do you have there? 0. It is important that you come up with the correct values. If you get wrong values, you are gone. What is the time? The time is indicated here in the first 10 seconds. So meaning your time is 10. Ah, no. This is supposed to be a 2 here. Okay. So I have a 2 there. Okay. So meaning the distance will be 2 into 2, 1, 2 into 10, that is 5. 8 plus 10, that is 18, times the 5, which remains that side. So meaning your distance is going to be 8 times 5, that is 40, remainder 4. 5 times 1, that is 1, that is 5. 5 plus 4, that is 90. Okay, so the distance in the first 10 seconds was basically 90 meters. And now they are saying, what is the average speed of the object for the whole journey? Question C. Okay, the average speed for the whole journey. Okay, so now remember, the formula for finding speed is equal to distance over time. We need distance, we need time as well. Time has been given to us, but we don't have distance for the whole journey. We just calculated distance for the first 10 seconds. So there are two ways you can do this. We know to say the distance for the first 10 seconds for this trapezium, okay, was 90 meters. So we can simply find the distance for this triangle, and then we add it to the 90 to get the distance for the whole journey. Or if you want, you can simply calculate the distance for the entire trapezium. Okay, meaning your A will still be this one up here, and then your B now will be from here to there. A is from there to there. Okay, your height is still going to be the same. So I would rather just calculating the distance for the whole journey. So I'll simply say A plus B, since we are dealing with a trapezium, over a 2. So distance is going to be, your A there, we said 10 minus 2 there, giving us 8. Okay, plus, what is our B? Our B is the distance from there to there. So 15 minus 0 is 15. Okay, and then what is the height? The height is 10, just like from the previous one, over 2. 2 there 1, 2 there 5. Okay, distance is equal to 8 plus 15, that should give you 23. Okay, 23 times 5, distance will be equal to 5 times 3 is 15, remainder 1. 5 times 2 is 10 plus that one, 11. So 115 meters. That is the distance for the whole journey. Now we can find the speed, the average speed for the whole journey. So we simply say speed is equal to distance over time. The distance is what we've just found here. So speed is equal to distance over time. Speed is equal to distance is 115 meters. Over the time, it's indicated here, average speed for the whole journey. The whole journey took 15 seconds. Okay, took 15 seconds. So meaning our time is 15 seconds. Meaning speed will be equal to, okay, so there we can reduce with 5. You can say 5 there, it's 3. 5 into 10, 2, remainder a 1. 5 into 15, that's 3. So we're going to have 23 over 3. 23 over 3. Speed is equal to 3 into 23, goes there 7 times, remainder a 2. Is it 21? Yeah, remainder a 2. 3 into 2, it can't go, we put a point, we add a 0. 3 into 20 goes there 3 times, no, 6 times. Okay, goes there 6 times, because it goes into 16. Remainder a 4. Okay, 3 into 4 there goes there just one time. So we can actually leave it at this point, 7.6 or 7.61 meters per second, since we're dealing with speed. And you are done. Go to the next question. The next question says, the following diagram is a speed time graph of a car. I don't have much to say about this one. Okay, so we have this diagram up here. Let's go to the question. Calculate the acceleration of the car during the first 5 seconds. The first 5 seconds from there to there. So this is a graph. So this distance, let's call this point B, and then let's go where it started from point A. That is the journey. It started at A, ended at B. Okay, so meaning your initial you're picking it at A, your final you're picking it at B. Okay, so I'm going to say acceleration. No, not a formulas are case sensitive. If it's a small letter, use a small letter. B minus U over the time. So acceleration will be equal to final is where it ended. It ended at B. So we check what's the value there. It's 20. So final is 20. It started from rest, so meaning our initial is 0. Okay. Time, what is the time indicated? First 5 seconds. So time is 5. So acceleration will be equal to 20 divided by 5, giving us what? A as 4 meters per second squared. And we are done. Okay, we go to the next one. Okay, or I can also clear this up. Knew that this guy won't appear. Can just erase it manually like that. Okay, next one says find question B. Find the value of t. Given that the total distance traveled was 550, find the value of t. Very interesting question. How do we find the value of t? So take note of what they have given you. What have they given you? This 550 meters, what is it? It is distance. So we are going to use the formula for calculating distance for the whole journey, okay, to find the value of t. Since they already given you distance, remember in any formula, they can only ask you to find one value. So if you look at the distance formula for a trapezium, a plus b height over 2. You can only find one of these things. It's either you're finding distance, it's either you're trying to find the one of the length or the other one, or you're trying to find the height. Okay, so in this case we already have distance, so meaning we just need to find the missing height. Okay, so our A is this one, our B is this one. A is the distance from there to there, which we can extract from these values. You can say 25 minus 5, it gives you what? It gives you 20. Okay, then the height is the distance from there to there, which we can extract by saying 20 minus 0. So height is equal to what? 20. Now, how about the value for B? B is the distance from there to there, which we can extract by saying t minus what? Minus 0. Okay, so B is just going to be represented by what? By t. So either is B, we're going to put a t. So we're going to say distance, again, distance has been given as 550. So either is D, I'll simply put 550, which is equal to, what is our A? Our A is 20 here. Okay. What is B? B is T. Okay. What is our height? Our height is 20. Everything over what? Over 2. So 550 is equal to, you can say 2 there 1, 2 there 10. So we're going to say 20 plus t. You can simplify those values over t. So here I'll divide both sides by 10. By 10, so that this and this one will be cancelled. Then here I can simply cancel the zeros, this one and this one, meaning I'll remain with 55 is equal to 20 plus t. So then this 20 can cross to the other side, so it's going to be 55 minus 20 which is going to be equal to t. 55 minus 20 will give me 35. Okay, we're dealing with time, huh? So 55 seconds, 35 seconds is the value of t. So meaning here at t, we have 35 seconds. So here we have 35. Okay, that's the value for t. So take note of what they give you. Sometimes they give you, given that the deceleration in the last how many seconds was this, find the value of something. Given that the acceleration in the first how many seconds was this, find the value of that. So they'll give you a value. That value they give you is what you're going to use to solve. So here they gave us distance. That is why I've used the distance formula. So in case they give you acceleration, use the acceleration formula. Just like that. Otherwise, it's a very, very simple question. You just need to pay attention to what they're saying. Calculate the average speed for the whole journey. Okay, so now the average speed is the same one as speed. Speed is equal to distance over time. The speed, the distance was given to us as 550 for the whole journey. Okay, so here all they're trying to do is, if your value for t was wrong, meaning you're going to get this question wrong, because the total time this journey took was 35 seconds according to what we have calculated. So if our 35 was wrong, then this value that we are going to find now would also be wrong, because we need to use it in this solution. Okay, but we're going to prove whether the 35 we found was correct or wrong. So at this point we can say 5 there, it goes there 7 times. 5 into 55, it goes there 11 times, so you can add a 1 there, so meaning I'm going to have 110. And add a 0. Okay, so speed will be equal to 7 into 11, that is 1. Okay, remainder what? 4. 7 into 40 goes there 5 times, 35. Remainder what? Remainder a 5. 7 into 5, it can't, you put a point there, you add a 0. 7 into 50 goes there 7 times, 49. Remainder a 1. 7 into that goes there, you add a 0 again to just give you ones. 7.11111. 15.71111 like that. So we can leave it here at 15.7. What is this? It is speed, so it's going to be in meters per second. And you are done. So now here comes the proof. That's 35 we found for the time. Was it correct or was it wrong? Let us prove. Okay, yeah, I like proving. That way, as I leave the exam room, I know to say that one I got it correct no matter what. Okay, so they've given us a distance, right? It is 550 meters. Let's assume that we didn't know the distance. Okay, but we knew the time, the 35 we found. Let us now try to find the distance for the whole journey. We see if we're going to get the same 550. So the formula is a plus b times height, everything over 2, of which our a we said is the distance from there to there. That's our a, which is going to be equal to what? 25 minus 5 gives us a 20. Okay, and then what is our b? B, we said this is the distance. Okay, this one to this one. So I'm just going to say 35 minus 0 gives us 35. That is our b. What is our h? Our height. Our height is this one here, the distance from there to there. How do you find the value? You are going to say 20 minus 0, giving you a 20 there. Plug in the values. Distance will be equal to, what is a? A is 20 here. Okay, plus what is b? B is 35. What is the height? Height is 20. Then everything over 2. Distance will be equal to 2 there, 1, 2 into 20, that's 10. Okay, 20 plus 35 here will give us 5 times the 10 which is outside, this one here. Okay, meaning the distance will be 550 meters, just as we are given in the question. Okay, so meaning we are correct. Tachonga correct. We now go to the last question. So the last question says the diagram shows a speed time graph of a particle the particle starts from rest and accelerates uniformly to a speed of 10 meters per second in 5 seconds. Okay, it then moves at this constant speed for 5 seconds and then accelerates at 2 meters per second for 5 seconds to reach a speed of v meters per second. Okay, so now here pay attention to the question. They have given us acceleration at this point. Okay, 2 meters per second. Let's take note of that one. Let's go to the questions. Find the acceleration during the first 5 seconds. Quite simple, this one. A is going to be equal to, acceleration is equal to v minus u over time. Now u looks like it's a 0. Now that looks like a v. Okay, what is the final velocity? So first 5 seconds, from there to there. Okay, you go up to the graph. It is this distance from there to there. So let's call this point A, this point B. So it moved from A to B, meaning B is where you're going to pick your final velocity. You go to the axis for speed. Okay, what is the value there? Your V will be 10. So it's going to be 10. It started from rest, so your U is 0 over the time is indicated here as first 5 seconds. Meaning acceleration is going to be equal to 10 minus 0 is equal to 10 divided by 5. Acceleration will be equal to 10 divided by 5, that is 2 meters per second squared. Remember, this is acceleration. Having found acceleration, we can proceed to the next question. Okay, hope I'm deleting everything. Okay, just this line. Okay, we now go to the next question. Find the value of what? The value of v. Where is v? V is this one, representing speed. Okay, this value here representing speed. How can you find the value of v? We go back to the question. We were given acceleration. Acceleration for which part? This part here. Okay, we've been told to say acceleration at this point was 2 meters per second squared. So that is what we're going to use. The journey starts from this point here, okay, this point here, and ended at that point. So meaning your initial velocity is this one here. This will be your u, your starting velocity. Your final, that's the v you're trying to find. Okay, your final is this v. So we're going to say acceleration is equal to v minus u over the time. Acceleration has already been given as what? 2 meters per second. So where there's a, I'll put 2. Why there's v, I don't know this value. Okay, there's just v there. That's what we're trying to find, the final velocity at this point here. We don't know it. The initial, it started from here, so we check this side. What is the value? It is 10. Okay, so our initial is 10 over the time. What is the time from there to there? Is this one, 10 minus 15 minus 10 gives you 5, plus in the question, oh, it's not indicated in the question, so that's how we find that value. So meaning we're going to say so at this point we simply say over 1 and cross multiply. Okay, 5 times 2 there will give us a 10, which is equal to v minus 10, and then the negative 10 will follow the positive 10. Group the like terms. So means it's going to be 10 plus 10 giving us 20 meters per second. Remember, v is representing speed, so that's the value of v. Okay, so remember this one is similar to the one we're from solving, where they asked us to find the value of t. So like I mentioned, pay attention to what they give you. Here they gave us acceleration, okay, and then they asked us to find v. So we need to use the acceleration formula to find the value of v. In the previous question they gave us distance, so just pay attention to what they give you in the question. That will help you solve the question. Okay, we now go to the next one. So here we have, what did you find for v? 20, right? Yeah, 20 meters per second. We may need it, so here we have 20. Okay, the last one says find the average speed for the whole journey. Wow. Okay, what the last question. So here, to find the average speed for the whole journey, we need to find the distance for this shape here, for this one here, for this one here. Okay, that is the distance we need to find for the whole journey. Okay, But we can combine these two shapes to form a what? A trapezium. So we can call this one distance 1. Okay, and then here we have another trapezium, which we can call distance what? 2. Okay, so for distance 1, okay, our A will be here, our B will be here. So A is the distance from there to there, which you can find as 10 minus 5. A is 5. Okay, B will simply be 10 minus 0, giving us a 10 as the value for B. Okay, so B is equal to 10. Our height is from there to there, so we can pick it from here. 10 minus 0 gives us 10. So meaning our H is equal to 10. Okay, those are our values for the first diagram. Let's put it here. So let's say distance 1 is equal to A plus B height, everything over 2. So distance 1 is going to be equal to our A here we found 5. So it's going to be 5 plus B is this one here, 10. Our height is this one here, it's 10 over a 2. So distance will be equal to 5 plus 10 is 15 times 2 there 1, 2 there 5 times 5. So distance 1 is going to be equal to 5 times 5 is 25, remainder 2. 5 times 1 is 5 plus that which remained 7. So we have 75 meters. That is distance 1. Go to distance 2. Okay, it's a trapezium as well. Okay, this one here. Okay, like that. And like that. So this will be our A, this will be our B, and this will be our H. Okay, so A, the distance from there to there, we can find it from here, 10 minus 0, so A is 10. Our height is from there to there, which is 15 minus 10, giving us what? 5. And then our B is the distance from there to there, which you can pick from here, 20 minus 0. So if that 20 was wrong here, it would be wrong there as well. Okay, so let's just capture the distance 1 as 75 degrees, so that we can create some space here. Distance 1 is 75 meters at 75 degrees. 25 meters, this is distance 1, so that we can clear the unnecessary work we have here. Okay. Okay, we can now plug in these values. We can actually bring it closer. We can now say distance 2 will be equal to A plus B height, everything over 2. Distance 2 will be equal to, what is our A? Our A is this one here, it's 10 plus B. What is B? B is this one here, it's 20. What is our height? Our height is this one here, it's 5. Everything over 2. So distance 2 will be equal to, we can simplify here the 5 and the 2, so we simply add 10 plus 20 gives us 30 times 5, everything over 2. We can simplify there, we can say 2 into 30, 2 there 1, 2 there is 15. Okay, 15 times 5 is 75 as well, right? 5 times 5 is 25, 5 times 1, 5 plus that 1, 75. Okay, so distance 1 and distance 2 are both 75. Okay, so now to find the distance for the whole journey, we simply add distance 1 plus distance 2. So 75 plus 75 gives us 150, right? Yes. Okay, so now don't lose track of why we're doing all this. So the final distance, let's call it distance 3, which is going to be equal to distance 1 plus distance 2. So distance 3 will be equal to 75 plus 75. So meaning distance 3 is equal to 150 meters. Now the question is asking us to find the average speed for the whole journey. To find the average speed, we need the distance for the whole journey. That is why we are calculating this distance. Okay, we need to plug it here so that we find the average speed for the whole journey. So in case you lost track of why we're doing all this, that is why. We need to know, for you to find the average speed or just speed, you need to know the distance. So we needed to calculate the distance for the entire journey. Okay, so when you have different types of shapes, simply calculate for each shape and then you add whatever you find at the end. Okay, so meaning we're going to say, what is distance? 150 right here. 150. What is the time for the whole journey? Okay, the time for the whole journey is indicated right here. It took how many seconds? 15 seconds. So that is the time for the whole journey. 15. So meaning speed will be equal to that's 15 going to 150. No, it doesn't. So we can say 5 there, 3, 5 into 15, 30. Okay, 3. 5 into 30 goes there how many times? 6 times. Wait, 5 into 3. What am I doing? I think I'm getting tired now. Okay, so 5 there, it's 3. 5 there, it's 3. We add a 0, meaning we've remained with a 30. Yes. So speed is equal to 30 over 3. Oh, 15 goes, oh yes, it goes into 150. Because it can also go into 75. So meaning our speed will be equal to 3 into 30 is 10 meters per second. This is speed, so it's just meters per second. And that's pretty much it. I think that is the last question. Yes, that's the last question. So as far as speed time graph is concerned, we are done. What I just need you to do is, the key to being able to solve this question is know how to find the distances for the three shapes we looked at: the triangle, right angle triangle, the rectangle, and the trapezium. Okay, make sure you know the formulas, especially for a trapezium. Okay, because that's the only one which is a bit different. So remember, distance for a trapezium is 1 over 2 open bracket a plus b close bracket h, or you can simply say open bracket a plus b close bracket h over a 2. Make sure you master that formula, and then whenever you're calculating distance, pay attention to the question. Okay, and be able to collect the correct values. Okay, there are times they are going to hide values. For example, like they have given us, they asked us to find a v here. In the previous question, they asked us to find a t. In the questions I'll give you, they also ask you to find other values. Pay attention to the question. Look at what they have given you. What have they given you? Okay, have they given you acceleration? Okay, if they've given acceleration and then they ask you to find one of the hidden values, it simply means you need to use the formula for finding acceleration, since they've already given you acceleration. If they've already given you distance, then you need to use the formula for finding distance for that particular shape to find the hidden value. Okay, so please pay attention to the question. Another important note to take note of is that, another important point to take note of is that the acceleration, when it at a uniform point, like a distance that was traversed uniformly, okay, or however you pronounce it, is the same. It does not change. Okay, so the acceleration from for example, I already put my pen down, let me get it back. Okay, the acceleration from here to there at this point will be the same as the acceleration at this point. This note is very important because you need to use it in the assignment I'll give you. Otherwise, that is pretty much it. We are done with the speed time graph, and then the test will be written on Sunday at 20 hours. We're going to have the end of the month test, and this one is going to cover all the topics we have covered in paper 1. Okay, so we are pretty much done with paper 1. We're just remaining with set notation, okay, which I'll cover in the the time I'll be solving the test I'll give you. So for now, we are done with paper 1. On Monday, we start looking at paper 2. Otherwise, for those of you who may be interested to join us, please feel free to join us. We are currently having online classes. Okay, otherwise that's pretty much it. I'll send the questions, and then tomorrow evening I'll solve the questions I'll give you today. Okay, so that in case you fail to answer the questions I'll give you, because some of them will be a bit tricky, I got you. I'll answer the questions tomorrow evening so that we can all be moving at the same pace. Otherwise, that is that. Thank you for watching, and I'll see you in the next one. Happy studying.